In section 37, we're going to be graphing piecewise functions, which is typically a really challenging section for many students. So go ahead and follow along. Starting with our entrance lib, this is just some previous problems. So this is from section 36. So go ahead and pause the video and complete these 4 problems. All right, so for hopefully number 1, you got the answer is to be 1. Number 2, our answer is 3. Number 3, our answer is 8. And then number 4, our answer is -6. So if you have any of these wrong, go ahead and pause the video and copy down the correct answers. And this, again, is a review from section 36. So we were evaluating each of the following. Just a heads up, if you notice something else that we were talking about in section 36 are those undefined answers. So notice that there is a gap in between these. So we could say that there is, our answer is undefined from -6 to -4. And with -6 to -4, that is the correct way of writing even the parentheses, okay? So because both of them were the less than or equal to or greater than or equal to, they had that equal to sign. So again, that is undefined. Those are our undefined answers. Not a question on here, but just something that we need to make sure that we recall from section 36. Okay, so to graph a piecewise function, the first thing that you're going to have to do is know when to put a closed circle, which is just labeled as a point, okay? When we put a closed circle, we're just putting a point. And this is any time that we have the less than or equal to or greater than or equal to sign. And anytime that it's a closed circle or a point, it's called included or a defined answer. Excluded or undefined answers are open circles, okay? So we have the less than or greater than symbol. So anytime that we see our inequality signs, we have to know when to put a closed circle or an open circle. The next thing that we're going to be doing is connecting endpoints, all right, with a straight line. And then on this course, we're only going to be graphing a piecewise function on an interval from -10 to +10. And the reasoning is because for all of our graphs, like if you look at all of these 6 graphs that we're going to be doing, anytime that you have an interval, that's talking about from x to x. So from when x equals -10 to when x equals +10, what's happening? Notice that the graphs only go from -10 to +10. That's why we're only graphing from between those two. So because we're only graphing in between those two, you're also going to put a point at the end. So we're not going to put an arrow. We're just going to put a little point, a little closed circle to indicate that is our starting and our ending point. Knowing that because it's a closed circle, it can go past that. Okay, so we can graph at -11 to 11, or that's possible for these because we could, but we're not going to because the graph doesn't go to -11 over here, or it doesn't go to +11 over here. So we can't graph past 10 and -10. So that's what we're going to be doing. So you're going to see that you have your piecewise function. I'm going to go ahead and highlight x plus 5. X plus 5 is anytime x is less than -3, and then in the following one we have -x plus 2, anytime that x is greater than or equal to -3. So this is our piecewise function f of x. So from there, what you're going to be doing is you're going to be writing out each of the equations separately. So we have x plus 5, and then we have -x plus 2. From there, I'm going to put my starting point. So we are starting at -10. So I've already pre-written this down. So we start at -10. And then I'm going to -3. The reason why we're going to -3 is because we have -3 right there. Now, unless it's otherwise indicated, you're always going to put a closed circle on the end. And then at -3, we're going to actually look at the inequality that's right next to it. And you notice that it's the less than symbol. So therefore, we have an open circle. From there, what you're going to be doing is plugging in -10 into x plus 5. So we're going to do -10 plus 5, and we get an answer of -5. So what I'm going to do is plot -10, -5. And we're going to go ahead and put a closed circle right here. After that, we're going to plug in the -3 into x plus 5. So we have -3 plus 5, which equals +2. So at -3, +2, I'm going to put an open circle. And then all you have to do is connect to make the straight line. Then I go on to the next line. So we have -x plus 2. So this time I'm starting at -3. So we're going in order. Notice that I'm going in from smallest x to largest x. So the smallest x is -10, the largest x is +10. All right, so starting at this one, so we're starting at -3. Notice that at -3, so I'm going to look at the inequality right next to it, we have the greater than or equal to sign. So we're going to put a closed circle there, and then of course at 10 we're going to put a closed circle unless it's otherwise indicated. And it would tell us right here. So if it told us like that we had to do the open circle, it would have said -3 less than or equal to x and then less than 10. So this is a time, so it wouldn't be this, it would look like this if we had to put an open circle right here. But it doesn't. So it's always a closed circle. So we're going to start at -3 and we're going to plug that into -x plus 2. So we have -3 plus 2. So we have +3 plus 2, which equals 5. So at -3, +5, we're going to put an closed circle. And then at 10, plug that into -x plus 2. If you want to put parentheses, you can. And we get -8. So we have 10 comma -8, and we're going to go ahead and put a closed circle. All we have to do is connect, and this is the graph for number 1. So this is my piecewise function. It's split up into 2 different lines separated by those inequalities, and that's it. All right, number 2. So let's go ahead and graph this. So we're going to have to start from we're going to go from beginning to end. So I'm going to start by highlighting. So here's the first one, and then we have our second line. So this is split up. So we have 1/2 x plus 6. So I'm going to start at -10, and then I'm going to put a blank. And then for this 1/2 x plus 6, we're ending at -6. And we just have to figure out what y is. At -10 comma blank, we're going to have a closed circle, and then I'm going to look at the inequality next to the -6, and right next to the -6 we have a less than or equal to sign, so it's always going to be a closed circle. Let's go ahead and plug in 10 into 1/2 x plus 6. So half of -10 is -5, so we have -5 plus 6, which is +1. So we're going to go ahead and put a closed circle at -10, +1. In the next one, we have -6 for x. So we have half of -6, which is -3. -3 plus 6 is +3. So we have -6, +3. Connect. Next, we have -x plus 4. So I'm going to go ahead and start at -4 comma blank, and then we're going to end at 10 comma blank. At -4, I'm going to look at the inequality right next to it. We have that equal to sign, so it's greater than or equal to, so closed circle. And then at 10, we're going to also put a closed circle. So we're going to plug in that -4. So we have -4 plus 4. If you recall, this is from our entrance slip, right? -4. So we have 4 plus 4, which is 8. And then we're going to go ahead and plot -4 comma 8. And then finally, we have to plug in 10 into -x plus 4. So we have -10 plus 4. We get -6. So we're going to go ahead and put a closed circle at 10, -6. And this is our piecewise function for number 2. Go ahead and pause the video and try out number 3 all on your own. Now, when you did number 3, hopefully you noticed that you were putting an open circle at 2, 2. Right here, we had an open circle from right here. And then in my next equation, we also had an open circle at 2, 2. So that just means that they connect. So we have our 2 lines connecting to one another with an open circle. Perfect. So we have that connection made, and we continue on with our graph. So this is, again, split up into 3 pieces, 1, 2, 3, gray, brown, blue. 3 pieces to make our piecewise function. We just have time for, we're going to do one more example together. Number 6. You could check the content library for numbers 4 and 5. So number 6. So in number 6, we have 4 separate equations separated by intervals or inequalities. 1, 2, 3, 4. So we're going to start with x plus 8. So for x plus 8, we're going to start at negative 10. So I'm going to put negative 10 comma blank, and I'm ending at negative 4. So we're going to have negative 4 comma blank. Yeah, at negative 10 something, we're going to have a closed circle as always, unless it's otherwise shown. And then at negative 4, it looks like we also have a closed circle. So then from here, what we're going to do is plug in negative 10 into x plus 8. So we have negative 10 plus 8, which is negative 2. So we're going to go ahead and put a closed circle at negative 10, negative 2, closed circle. So we have to plug in negative 4. So we have negative 4 plus 8, which is positive 4. So we have negative 4, positive 4, and we have a closed circle. We're going to go ahead and connect. All right, next one. So my next one, we have negative 2x minus 4, and we're starting at negative 4 comma blank, and we're ending at 2 comma blank. So we have the possibility of a connection right here. We have a possibility of a connection. Now, if the y's end up being the same number, then they connect. If the y's are a different number, then they don't. So what I'm going to do is, so we have an open circle and then another open circle. So what we're going to do is plug in negative 4. So we have negative 2 times negative 4, which is positive 8. And then we have 8 minus 4. 8 minus 4 is 4. So we do have a connection made right here. So these are going to connect. Now when I go here, I can put that open circle around it just so that I remember that it connects. But because we have that closed circle already there, all right, we have a point indicated. So we're going to leave that. If we started with an open circle and then after that it was a closed circle, you'd have to fill it in. So those open circles always get filled in by closed circles. So we're going to actually have a connection with a closed circle because of the previous, because of that x plus 8, we had a closed circle at negative 4, 4. Okay, then we go on to the next one. So we're going to plug in 2. Negative 2 times 2 is negative 4. Negative 4 minus 4 is negative 8. So we have 2 comma negative 8, open circle. And then we have to connect. Next one, we have x minus 10. So we have 2 comma blank, and then we have 6 comma blank. At 2, I'm looking at the inequality next to it, open circle, and then at 6, I'm looking at the inequality next to it, open circle. So let's go ahead and plug it in. So we have 2 minus 10, which is negative 8. So check it out. Right here, we have a connection. Now, if I were to overlap this, it would also just be an open circle. So just a connection made, we're going to leave it open because we never had a number to, never had a closed circle to fill it in. So we did have a connection there. And then x minus 10 is ending at 6 comma something. So we're going to do 6 minus 10, which is negative 4. So we're going to go to 6, negative 4, and put an open circle. And then connect. And then finally, we're ending at some line of negative 4. So for this line, we're starting at 6, and then we're ending at 10. At 6, we're going to put a closed circle, and then at 10, we're going to put a closed circle. Now when I plug in the 6 and a negative 4, there's no x to plug it in, so it's just negative 4. So check it out. We do have a connection made. So these connect. So what I'm going to have to do is I'm going to have to fill in my closed circle. So we're filling it in. And then finally, we're ending at 10, negative 4. Closed circle, connect. So this is my entire piecewise function for my graph of function named P. The whole thing, so this whole thing ended up connecting into 4 different pieces. But just be really cautious when you connect. Make sure that you're checking out those open and closed circles. You might have to fill some in, but if you have 2 opens on top of each other, you do not have to fill those in. You're only filling in if you end up with a closed circle. If you need any help, please be sure to email me or ask me during class.